Hello students, let's solve this question. A gun crew observes a remotely controlled balloon launching an instrumented spy package in enemy territory. So, with the diagram you can observe that there is a balloon here. Okay, so this is launching some kind of a spy instrumented package in enemy territory. When first noticed, the balloon is at altitude of 800 meter. So, balloon is observed when it is at the altitude of 800 meter, moving vertically upward at a constant velocity of 5 meter per second and 1600 meter away. So, definitely someone is observing from here and the balloon is at 1600 meter distance and it is at some altitude which is also given to you is 800 meters, and the balloon is moving upward with a velocity of 5 meter per second. Shells fired from the gun have initial velocity 400 meter per second. So, the person or sipahi sitting here is trying to fire on this shell, fire on this balloon. The shells of the shells are fired with a velocity of 400 meter per second and the angle theta is fixed and the angles cos and sin is also given to us. The gun crew waits and fires so that to destroy the balloon. So, the sipahi here is waiting for some time and then he is firing so that his shell is definitely going to hit the balloon. G is given as 10 meter per second square and we need to neglect air resistance. What is the flight time of the shell before it strikes the balloon? If you read out the question properly, you can see that there is a angle of the projection is fixed. So, if the angle of projection is fixed, so there is a fixed path on which this shell is going to move. There is a fixed path on which this shell is going to move, and that path, with that path cuts the path of the balloon, then definitely at that point only balloon can be destroyed because the path of the shell is fixed. So, when shell is reaching this vertical line which is at 700 meter distance away, then only balloon can be destroyed, and this vertical line is at 600 meter distance away, and the velocity of shell in this horizontal direction you can determine it. It is going out to be 400 into cos theta, as cos theta is given as 4 by 5. So, it is going out to be 320 meter per second. So, shell's velocity in horizontal direction is known to us, and in horizontal direction it needs to cover 1600 meter distance in order to hit the balloon. So, the time taken should be the distance travelled by speed with which it is covered. You can calculate it. So, 16 by 2, this is going out to be 5 seconds. So, in 5-second time the shell is hitting the balloon. In part 2, we need to find what is the altitude of the collision. We need to find the altitude at which the collision is happening. So, in order to do it, the velocity in vertical direction of the shell is known to us. It is going out to be 400 into sin 35, sin 3 by theta. So, 400 into sin theta, it is given to us as 3 by 5. You can calculate it. It is going out to be 240 meter per second. 240 meter per second. So, the velocity of shell in vertical direction is known to us, and in vertical direction it is covering the distance in 5-second time. So, the displacement can be determined. It is going out to be ut, which is 240 into t plus half g is in downward direction. So, I will take it as negative minus 10 into t square. 5 square will be 25. You can calculate it. So, it is going out to 20 this 240 into 4. So, it is going out to be 1200 plus 25 into minus of this 5, it is going out to be minus 125. 1200 minus 125, it is going out to be 1075 meter. So, this is the altitude at which the shell is hitting the balloon. Now, if you observe the altitude obtained here, it is greater than the altitude given in the question of the balloon initially. Balloon initially was at altitude of 800 meter and our shell is hitting balloon at this height. So, definitely balloon need to rise by a distance of 1075 minus 800 meter in order that shell is able to hit it. So, this distance, if you read out the question, the balloon is moving up with a constant velocity. So, this distance is covered in constant speed, with constant speed. So, the time to cover this distance, the extra time, let us assume that is t naught, will be the distance upon speed. So we can solve this expression to get the time when balloon is reaching the height of 1075 meter. So if you divide this equation, if you solve this expression, so it is 275 by 5, it's going out to be 55 second. So balloon is at 55 second reaching the height when shell is hitting it, but shell is reaching that point after 5 seconds it was launched. So if 55 seconds is the total time required by balloon to reach that point, and balloon and shell is hitting it after 5 seconds, so before 5 seconds it should have been fired. So the time at which shell needs to be fired is 55 minus 5 or 50 seconds. So after we have noticed the balloon, we need to wait for 50 seconds, then fire the shell, and that shell is going to reach the balloon in 5 second time, and shell is going to reach this height to hit the balloon. Thank you.